Today's lesson is on the triangle inequality theorem. And to do this lesson the right way, you're going to need some colored sticks that I can make available to you. And then do that, we're going to discover the triangle inequality theorem using those sticks. Then we're going to define exactly what the triangle inequality theorem is. Then we're going to figure out how to use it and go over a couple different kinds of problems. So the first thing, if we're going to make some triangles, we have these colored sticks. Got a very big orange one, then a little bit smaller blue one, a little bit smaller than that yellow one, a green one a little bit smaller than that, a purple one, and then finally a bright yellow or a bright orange one that is very small. So if I ask you to make a triangle with one of the big orange sticks, a blue stick, and a yellow stick, you could make a triangle that looks like this. If I ask you to make a triangle with a big orange stick, a yellow stick, and a green stick, you'll be able to make a triangle that looks something like that. If I ask you to make a triangle with the blue, green, and purple, you can make a triangle that looks like that. And finally, if I ask you to make a triangle with a big orange stick, a purple stick, and a little orange stick, there's my big orange stick, there's my purple, and there's my little orange, and they never actually reach. That purple one and the orange one are too short to be able to reach and make a triangle. So I can't actually make a triangle with those three sticks. So what's the rule for making triangles? Why were we able to make some triangles, like the first one we made, the big orange, blue, and yellow, the second one we made, the third one we made, the blue, green, purple, but not others, the big orange, purple, little orange? We couldn't make that one. Why not? Why couldn't we make that one? So what's the rule for determining if the three sides make a triangle? And so the rule is that the sum of the lengths of any two sides of a triangle have to be greater than the length of the third side. So if I have a triangle with three sides, A, B, C, what that means is that A plus B has to be bigger than C, and A plus C has to be bigger than B, and finally B plus C has to be bigger than A. If you think about it though, there's an easier way to state all this, which is that I know that by definition the longest side, if it's going to be bigger than the other side, than any other side by itself. So if the other two sides aren't going to be long enough, then I could restate this as the sum of the two shortest lengths of a triangle has to be greater than the length of the longest side. So going through the three that I had before, in this case C is my longest side, so A plus B has to be bigger than C, and the other two I don't have to worry about it, because I know if A plus B is bigger than C and C is my biggest side, then by definition the other two statements are going to be true. Alright, so there's a triangle inequality theorem. How would I use that? Well, what if I was asked, can a triangle have these given lengths? Could it have the length of 3 feet, 7 feet, and 8 feet? Well, 3 plus 7 is greater than 8. Yes, that's true. 8 plus 7 is greater than 3. Yes, that's true. And 3 plus 8 is greater than 7. Yes, that's true. So could I make a triangle with these lengths? And the answer is yes. Yes, I could. Let's try a second problem. What if I had lengths of 3 centimeters, 6 centimeters, and 10 centimeters? Can I make a triangle with those lengths? And I notice if I add the two smallest lengths together, that is not larger than the largest side. So again, like that last triangle we tried to make, those two sides are not going to reach. So the answer is no. No, I couldn't make a triangle with those lengths. And the reason is because that the sum of 3 and 6 is not greater than 10. It contradicts the triangle inequality theorem, so I know that it can't be done. Another kind of problem that we have, instead of giving us three sides and saying, could I make a triangle with this, is giving us two sides and then determining how long the third side could be. So if I know a triangle has sides of lengths 8 centimeters and 10 centimeters, what could the lengths for the third side be? Well, once again, I know that I'll let x represent the third side, and then because of this triangle inequality theorem, I know that x plus 8 is greater than 10, that x plus 10 is greater than 8, and that 8 plus 10 is greater than x. And if I simplify those, I have x is greater than 2, x is greater than negative 2, and x is less than 18. So if I combine all those, I finally find out that the third side must be longer than 2, but shorter than 18.